Hi guys, today I'm going to be working from our Jacplus textbook and we're going to be doing 2.3 and this is the second video in 3 that I'm making to go through the worked examples. So today we're looking at worked example 5 and we're solving for x. So if you haven't done the first video yet from 2.3, you should do that first because this one's a little bit harder. Alright, so look, we last time looked at examples where we had to solve, and it's the same idea. What we need to do is move everything we can over to the right hand side. So 2 sine 2x equals 1. So I've added 1 on both sides, and now I'm just going to divide by 2 on both sides. So now we have an equation which is pretty, pretty straightforward. We can see that half is a value for sine in the table of exact values. So we're doing well. Now, look, some people like to change the domain when doing a question like this. So you can change the domain because we've got 2x in here. But I like to do it a different way just because I feel people understand it a little bit better in this way. So if you have learnt to change the domain, that's fine, but still bear with me, have a look how this works. You might like it better. So what I'm going to do, I'm going to say let z equal to x, and then, well, now I can say sine z equals half. And now I can do exactly the same way as what I did in the previous example. So example 4, I think, yeah, example 4. So let's draw it. And I'm going to draw my basic angle, which in this case is pi on 6, remembering that because our domain includes 0 to 2 pi, we can see that we're going to be working in radians here. So this is pi on 6 in here. And we know that sine is our vertical height of the triangle. So if sine is the vertical height of the triangle, this means that this length here is half. So this is our basic angle, and this is the basic angle is always in quadrant 1. We now want to think about where we would get positive for sine of z. And remembering that we are illustrating for z here, not x. Z equals 2x, but we're not going to consider that until the very end. So sine is half. Positive half in the first quadrant, so that's good. The other one we want is over here. So again, this height of the triangle we're looking at, and that's going to be half, positive half, and then this angle in here is going to be pi on 6. Remembering that the triangles that you draw have to be part of the butterfly, so it would be like this as a butterfly. So the 2 triangles I've drawn are both part of those wings. So now I can say, well, let's name the angles that we get. And remembering that our domain is from 0 to 2 pi, but we're dealing with z. So I'm going to say z equals pi on 6. And z equals, if we start at 0 and we go around to here, then that's going to be all the way around would be 6 pi on 6 all the way till there. That's 6 pi on 6. Minus pi on 6 because we go backward. So in other words, our angle drawn in yellow there is 5 pi on 6. So I'll add that. Now let's see, we have our z angles there of pi on 6 and 5 pi on 6, but z has nothing to do with this question, so we need to sub back in the 2x. So I know that z is in fact 2x. So we've got 2x equals pi on 6, and that means x equals pi on 12. And that is one of our answers because, well, pi on 12 is well within the domain of 0 to 2 pi. So that one works. Let's go for the next one, 5 pi on 6. So that means 2x equals 5 pi on 6. And now I can solve that to get x equals 5 pi on 12. And again, that is certainly within the domain. Now, if you're not really sure, you could say that 2 pi is 24 pi on 12. So because we're getting a denominator of 12, it will be easier for us to see when we get too high. Let's go around the circle again. So I'm going to go back here And now I'm going to go from 0, and remembering from the last video, I labelled pi as 6 pi on 6, and I labelled over here as 12 pi on 6, or in other words, with a common denominator. So I'm going 6 pi on 6, 12 pi on 6, and then plussing another pi on 6. So that's 13 pi on 6. So I can say z, not x, is 13 pi on 6. And well, let's now change that to 2x is 13 pi on 6. And that means x equals 13 pi on 12. So again, this is well within the domain of 0 to 2 pi. Remembering 2 pi is 24 pi on 12. So we still could go further. So I'm going to do that. So now I'm starting at 0, 6 pi on 6, 12 pi on 6, 18 pi on 6, minus pi on 6, I'm going backwards. That's going to give me 17 pi on 6. So I have z equals 17 pi on 6. That means 2x is 17 pi on 6. And then, well, I can divide by 2 on both sides. That gives me x equals 17 pi on 12. So now, again, that is within the domain. So I'm going to highlight that so I don't lose it. And noting, because you have a lot of working out for these sort of questions, so good idea to make sure you're really clear which answers are actually included, because you could go past, and as we will in a second, and then you want to make sure you don't include ones that are too large or too small for the domain. So I'm going to do one more. I can see that I'm not going to have any more solutions, but just to show you, I'll do one more. So we have 6, 12, 18, 24, 25. So that means that z equals 25 pi on 6, and you can probably already see how this is going to be too large, but let's continue it for the sake of completeness. 25 pi on 6, and then of course x equals 25 pi on 12, and this is outside the domain, so I'm not going to be including that one. So my 4 solutions are here highlighted, and as I said, you could alter your domain. That's not the method I'm going to show, because I think this one is far better for understanding. Let's move to the next example. So there's one more, and this is a cos one, and this one's a little bit more tricky, because, well, our cos 2x minus pi is a lot more convoluted than just cos x, for example. So look, let's see, I'm going to undo the equation as per usual. So I'm going to have 2 cos 2x minus pi equals 1. So I've added 1 on both sides, and then cos 2x minus pi equals half. So at this stage, this is where I'm going to use the z. And of course, you can use any pronumeral you want. So let z equal 2x minus pi. So that means, therefore, cos z equals half. And you need to state this, and this for that matter, because you're adding a z in out of nowhere. You're using it for your own convenience. So you want to state why you're using that z, or what it represents in your working out, if you do choose to use this method. So now that we've got that, let's look in the table of exact values, which, by the way, you need to memorize. Of course, there's the video which shows you how to derive the table of exact values. You might have a memorization technique that you use, but in any case, you're not going to be given that, so you need to actually know the table of exact values. So there's half in the cos column, and then we head on across here and we see that it's pi on 3. And again, we're using radians because we'll look at the domain. It's in radians. So let's see. We've got z equals pi on 3. So I'm going to draw that, and again, I'm not even going to worry about positive and negative yet. I'm just drawing it in the first quadrant, so I see my basic angle. So this is pi on 3. This is the triangle, the right angled triangle there, and now the cos value is this. So it's the base length of the triangle, and the cos represents the x coordinate. So this here is half, this length is half, What's going on? There we go. So that length there is half. And we can see that, well, it's going to be positive here. So that is one of the triangles we want to use. It's not positive here. X is negative over here. X is negative here as well. Where else it's positive is in this quadrant here. So don't be confused with sign. Triangle doesn't look very good. I shall rub it out. That one neither looks very good. But anyhow, pretend that's a nice right-angled triangle. So the point is that our base length is half, and the angle in the triangle that makes a base length of half is pi on 3. So now we can just go around the circle and find the angles that are going to be relevant. So Z, that might Z equals, and our first Z equals would be, well, pi on 3. So I'm just going to put that on. And I'll do another one. I'm going to go around to here, and that will give me Z equals, let's put a common denominator, 0, 3 pi on 3, 6 pi on 3. So we've got 3 pi on 3, 6 pi on 3, minus pi on 3, that's 5 pi on 3. So Z equals 5 pi on 3. And then, well, let's see what those equal when we when we put back our x. So that means 2x minus pi equals pi on 3. So remember, Z we substituted for 2x minus pi. So now I'm putting it back in because we're solving for x. We're not solving for z. So now I'm going to, undo it. So 2x equals pi on 3 plus 3 pi on 3. So that's going to be 4 pi on 3. And x equals, divide by 2, 4 pi on 6. So that's going to be 2 pi on 3. And let's see, is it part of the domain? We're going from negative pi to pi. Yes, it is. So that one, well, I highlighted a little bit prematurely, but yes, it is part of the domain. So that's one of our answers. Let's go to the next one, which is 2x minus pi equals 5 pi on 3. So again, we're going to go 2x equals 5 pi on 3 plus 3 pi on 3. Of course, we're adding fractions, so we are common denominator. So it's going to be 2x equals 8 pi on 3. And then we're dividing by 2 on both sides. X equals 8 pi on 6, which is going to be 4 pi on 3. And, well, that one is too big. So that's too much. I'm going to cross that out. That is not one of the answers. So we've got one answer so far, and what people are going to forget is that you also want to go in the negative direction. So we've got negative angle, and even if we didn't have negative angle, sometimes when you've got a bit of a more tricky angle to work with, so this is 2x minus pi, or if you have 2x plus pi, or whatever it might be, your negative angle may actually end up or your negative result for z may actually end up being a positive result for x. Let's do this one anyway. So let's go this way. It's negative pi on 3, so z equals negative pi on 3. So let's see what happens here. 2x minus pi equals negative pi on 3. And then let's solve it. So 2x equals neg pi on 3. And this is exactly what I was talking about, plus 3 pi on 3. So I'm happy about this. This is a good example. 2x equals positive 2 pi on 3. So you can see that our x value here is going to be positive. So now we can divide by 2 on both sides, 2 pi on 6, which is pi on 3. So you see, even though our z angle was negative, the x angle that results from that becomes positive. So, and that is still part of the domain pi on 3. It's between negative pi and positive pi. So we'll leave that one, we'll highlight that one. Let's go for another one. So now I'm going to go all the way around to the second angle. So I start at 0, minus 3 pi on 3, minus 6 pi on 3, plus pi on 3. That's negative 5 pi on 3. So let's pop that one in. Z equals negative 5 pi on 3. And now we can undo it. 2x minus pi equals neg 5 pi on 3. So I'm going to add 3 pi on 3. 2x equals negative 5 pi on 3 plus 3 pi on 3. And this one will be negative. 2x equals negative 2 pi on 3. Divide by 2 on both sides. X equals negative pi on 3. So that also is within the domain. So let's highlight that. And let's go to the next one. So you see, what I like to do when I use this method is to continue until I go a little too far. Unless I can obviously see that I've covered all the solutions, I would do one more until I see that it's outside the domain. So let's go around again. Negative 3 pi on 3, negative 6 pi on 3, negative 7 pi on 3. So Z equals neg 7 pi on 3. Alrighty, almost there. 2x minus pi, so 2x minus pi equals neg 7 pi on 3. And now we can add 3 pi on 3 on both sides. Neg 4 pi on 3. And I'm going to divide by 2 on both sides, which is going to give me negative 2 pi on 3. So that'll be negative 4 pi on 6. So then, simplify it to negative 2 pi on 3. So there we go. And look, I think that's the last one, but let's go one more just to make sure, because, you never know. So let's see, negative 3 pi on 3, negative 6 pi on 3, 9, 12, negative 12 pi on 3 plus pi on 3, negative 11 pi on 3. So let's do that. So Z equals neg 11 pi on 3. And that means 2x minus pi. And then, well, let's add 3 pi on 3 on both sides. So that's 2x equals negative 8 pi on 3. Let's divide by 2 on both sides. So that's negative 8 pi on 6, which is negative 4 pi on 3. And this is not within the domain. So our domain goes from negative pi to positive pi. So negative 4 pi on 3 is too small. So look, for that one, our solutions are 2 pi on 3, pi on 3, or 2 pi on 3, pi on 3, negative pi on 3, and negative 2 pi on 3. So it just so happens that we've got the positive and negative of each of those angles. So negative and positive pi on 3 and negative and positive 2 pi on 3. So you should not assume that this would be the case. That's all for that example.